I'm real excited to introduce our next speaker. This young man, William Lucas, is potentially going to be credited with a major astronomical discovery in a very unusual way here in Madison, Alabama, which is a suburb of Huntsville, where I also happen to live. And I think you'll enjoy his presentation and be inspired by the next generation who are following us, and that's exactly what we need to do. We need to have inspiration in science and technology for this next generation.
Good morning, everyone. I'm William Lucas. It's a great privilege for me to be here today. Thank you very much to everyone who has helped to make this event happen. I'm here today to talk to you about the deep space object known as GRB 110328A. This object is also known to the astronomy and astrophysics community by the designation Swift-J 1644+57. It's been nearly 2 years after its discovery. Some of you are probably wondering why I'm discussing it today. The events of which you are about to hear and the data you are about to see have never before been publicly disclosed. These events are factual and have been witnessed by experts, questioned by experts, are well documented, and are now presented to you. I should also mention that I am not an astrophysicist, I am not an astronomer, so please bear with me on the tech stuff. I have tech people who have helped me. I am the owner-operator of Rocket Station here in Huntsville. This is a privately owned civilian-operated radiation monitoring station which runs almost continuously, measuring and recording the background radiation levels at my location. That's my best employee right there. This instrument is the essence of Rocket Station. This is an inspector plus Geiger counter manufactured by SE International and marketed by the Radiation Alert Company. It is a current model used by geologists, hazmat, homeland security, universities, and many other organizations. You see it here with its dust and humidity protector, a simple Ziploc bag. Connected to it is a computer connector cable linking it to a USB port of an HB network that is exclusively dedicated to this counter. This instrument is capable of detecting alpha, beta, X-ray, and gamma-ray radiation at mid to high levels. Notice the calibration sticker on the face of the instrument. It is certified. Rocket Station uses computer software marketed by the Geiger Company that allows me to count overall radiation levels in the immediate area. It does not allow for the separation or itemization of counts per type of radiation. Here's a typical radiation graph taken last year. It shows a moderate background level of 40 counts per minute. It shows each different type of radiation detector has a different normal average background reading. We call this reading a baseline reading. From this baseline background reading and an average CPM, almost anyone can see any variations from this normal condition. Here is the radiation. Here is the radiation network. It is an international network of people who operate their own radiation detection stations, just like me. It's based here in the United States in Arizona and is privately owned and operated. You can go online to theradiationnetwork.com and see a map of the US or other countries where the other detection stations are. There I am in Huntsville with the average of 38. This is what the radiation network looked like in early 2011. barely 12 stations. Typically, only 4 or 5 stations would be online nationwide, truly. Notice that there were very few stations in the entire South. This is of some serious concern because there were almost no other stations to confirm any readings and trends that I might record. Then on March 11th, 2011, 2:45, Then on March 11th, 2011, 2:45 p.m. Japan time, a magnitude 9.0 earthquake occurred just off the eastern coast of Japan. On March 12th, the nuclear power plants at Fukushima lost all electrical power to their core cooling systems and began a series of core meltdowns and explosions. Radiation clouds were drifting towards Canada and the United States, then on towards the rest of the world. ETA for the clouds to reach the west coast of the U.S. was 7 to 9 days, and 2 to 3 more days to reach Huntsville, Alabama. March 23rd or 24th was the best estimated prediction for Fukushima fallout reaching Huntsville. Here is a summary of rocket station radiation readings for March 20th, 2011 through March 28th, 2011. In fact, you can see how the average CPM smoothly but significantly rises from 38 counts per minute on March 23rd to 43 counts per minute on March 24th. However, by March 28th, the average CPM begins to smoothly fall again. Then an amazing thing began to happen. On March 28th, 2011, at about 6:50 a.m. Central Daylight Time, rocket station's radiation readings began to climb. My Geiger counter readings started climbing seemingly out of control for about an hour, while almost no one was aware of it. You see, it was a clear, calm, beautiful Monday morning, and everyone in the family was rushing about getting ready for the day. By 7:20 a.m. Central Daylight Time, I and my family were out the door and off to school. But at 7:21 a.m. Central Daylight Time, my radiation alarms began sounding and warning signs flashed up on my computer. While a dozen state and federal agents later those that stormed my living room that morning bear witness to the validity and accuracy of my readings. If the agents hadn't ordered my equipment to shut down, we would have had better resolution of the events. But by the quick thinking and courage of my father, all my data was saved. Well, it took several of us. Well, it took several of us all working together over a year to make sense of it all. One of my tech people studied the graphs and data from 2 different perspectives and said it looks like there are 2 different events recorded on the superimposed over the other. He said we see that all the time on process control charts. In this case, I have the low curve, most probably of Fukushima's fallout. Then there's the strange spike superimposed over it. When the world is the spike? he wondered. Yet the spike looks almost like a slightly inflated, slightly skewed bell curve. I had eliminated all other possible sources of radiation. Not Fukushima fallout, not from any planets or moons, no earthquakes stirring up atmospheric dust that might be charged, no earthquake-released radon gas, no rain or clouds, no fires, no radioactive calibration devices. Mom won't let me have one. Too dangerous, she says. No radioactive neighbors. No crashed planes. What's left? I wondered. Space aliens? Conspiracy theory? Beam weapon bounced off the moon by accident? This was an estimated 3.5 hour or longer event. Why didn't anyone know anything about it? Do an internet search. For what? What's left? Just search by the date. Oh sure, that'll work. Well, why not? It just couldn't be that easy, but there it was, in giant bold headlines. March 28, 2011, GRB 110328A, Gamma Ray Burster. NASA's Circular GCN 11823 and the Swift GRB catalog identified the time of discovery by Swift Burst Alert Telescope, X-ray telescope, triggered on a gamma ray source at 12:57:45 Universal Time on March 28, 2011. This source is believed to be a supermassive black hole at the heart of a galaxy about 3.9 gigalight-years away in the Draco constellation, a monster. How is it even possible, you may ask, that my Geiger counter could have ever picked up a gamma ray burst from somewhere deep in the Draco constellation? We regressed the early morning sky using an astronomy program, Cybersky 5, back to the morning of March 28, 2011. What we found was stunning. We found that the coordinates for the object right ascension 1644 50.0, declination plus 57 34 59.13. This location was almost directly overhead in the early morning sky within 24 degrees of zenith, the relatively thinnest part of the sky, right in front of the dragon's mouth. In conclusion, I, William Neville Lucas, do hereby claim the right of discovery by first detection of the deep space object commonly known as GRB 110328A.
Questions?
What got you into the detection business in the first place?
Well, at the time, I was first very interested in Geiger counters. Like, I really wanted to. At that time, I was very concerned of nuclear war or radiation leaks, and that's why I wanted a Geiger counter.
Okay.
And
On his 13th birthday, we gave him a choice. Do you want a dirt bike or a Geiger counter? And he chose a Geiger counter.
Any other questions?
yeah,
Now that you've had the Homeland Security guys and their instruments, how do you feel about their instruments as compared to your instruments?
They're the same.
well, they're the same.
They were the same. They came in with Inspector Pluses. And they said, this kid's got the same thing we do.
All over the neighborhood.
all over the neighborhood.
Could you take just a minute to relay the story of what that was like? Because that is an incredible part of the story, please.
Oh, it was, my husband was home, he'd just taken a shower, so he didn't hear the alarm go off. He was upstairs. So he went to the phone.
Come up to the mic, too.
Oh, so he heard the phone and it kept ringing and ringing, and he goes, oh, I'm going to work, forget. And then he said, oh, Huntsville Fire Department, I better take this call. So, yeah, so he picked up the phone. They said, you have a Geiger counter radiation situation at your home. We were called and informed by your systems operator. Oh, okay, I don't think I do. I don't have a Geiger counter. I don't have anything. He'd forgotten because it's his son's, his 13-year-old son's. So we never thought it was his because he's, right, we're thinking kid, not network. So then they called back. They said, well, maybe it's a mistake. So they called back a second time. They said, there's no mistake. We're coming over. So Rich said, okay, I'm staying home. He called me, honey, come home right away. Everybody's coming to our house. I said, okay. So I drove really fast home, and I was behind a man who was weaving in a gigantic white truck with the rubber tarp over the back, so it means electronics, but I didn't know that then. I thought, well, it's 5 of 8 in the morning. I'm behind the only drunk in Edgewater. You know, 5 of 8, he's coming home from a bar. Lucky me, I've got to get home. So I shot past him, and I looked in the cabin. This was a young man about 30 years old, so he was not a drunk coming home from it. And now I'm getting kind of scared because we're hearing all these people are coming over. So I shoot in the driveway, and I look in my rearview mirror, and he kind of smiles. He goes, that must be Mom, because that's the house he's focused on. And so then we came to the door, huge trucks, which I took a picture of. We have one picture, it's on my phone, of hazmat, of the fire department. SWAT was there briefly, and they left very frustrated because we were just a family, and they did not get to shoot anyone. I know, darn, they were frustrated. But they left right away because they didn't know what we could have been. They didn't know if Mom was just walking the dirty nuke past the Geiger counter and forgot it was there, because they were not getting readings from outer space. There were no readings from Swift or Chandra. So because we were 7 minutes before, 8 minutes?
1 hour and 7 minutes.
1 hour, 7 minutes before space picked it up, they didn't know what we were. So they were really serious. And it was interesting, as a civilian, when they walked up the stairs, they looked at me, they said, you look like a mom, but if you're not going to fool us. And that was, you know, and that was the look in their eyes, because it was very confusing from their point of view. Why aren't there, and all the detectors on the ground were picking it up in Huntsville, but space wasn't picking it up, so I can't stress that enough. Well, by the time they left, I'd offered them chocolate chip cookies, which they couldn't take because it was over their limit until the Air Force came, and the Air Force said it was okay to take the cookies. And then they left, and they were smiling. The Air Force can smile, no one else smiled, but they did go through the whole house and under the house, and we're totally cleared. We're not evil, we're not terrorists, we don't even have tester isotopes.
And it wasn't a fraud.
And it was not a fraud. And my son wasn't there because at 13 years old, you can potentially be accused of a prank. It was not a prank.
May I just say, I think most of the people in this audience are totally jealous of you right now. You did was totally awesome. The spirit of free scientific inquiry. And let us know if you get any static about claiming first discovery. Clearly belongs to you, so I'm sure there's enough well-connected people here who can run some interference for you.
Have you had the IAU accept that claim yet, or name it or anything?
No, this is the first time we've ever exposed this to the public at all. I mean, after having federal agents go through your house, you're kind of reluctant to talk about it for a year.
No, you need to file this. You need to make sure you file it.
Also, we got a call from the State Department saying we had to wait a year to talk about it because of the Japanese element and the radiation from Fukushima.
We know people at Harvard who log discoveries like this, so
Okay.
just
We
you have
need
a
help.
network now
We need help.
working
Thank
for
you.
Yes, sir.
So the only way the local authority knows about it, about your house, was your detector was online.
Yes, on the International Radiation Network. And the system operator called them.
your background data you were showing earlier that the Huntsville area had 38 counts per minute normally. Have you figured out why it's higher? I can tell you why.
Why?
We'd like to know.
Yeah.
Actually, it's not Browns Ferry. It's not.
Timmy's a nuclear engineer from TVA, so
He's by
just to let you know.
What it is,
Yeah.
it's based on the weather pattern. Stevenson, Alabama's Willis Creek fossil plant,
Oh,
and Colbert fossil plant, Sheffield. And through the tall stacks, 1,000-foot stacks, they have polonium and radon.
oh.
So that's why your count is just slightly higher here. So that's two radiation sources you didn't really think about. You missed it because
We were
very few
aware.
people talk about that.
We were aware of that. We couldn't really include all of the variations of this story. There's so much more information to this. Trust me on this. There's a
Ash
huge
out of
volume of
fossil
information.
plants is a lot hotter than you think it is.
Yes.
That's why they can't use it to make bricks for houses, but they can use it for roads.
We tested the rocks in the pond outside, believe me.
And his sister's head.
But that's still not going to, that's just going to raise the background. That's not going to create.
It's harmless.
Well, most of the elevation we found was actually on the ground floor. We found that it went back to a reasonable level on the second floor of the house. So there is something relative to the surface, the soil or something, but it wasn't the geologic material that had been brought into the area for architectural purposes.
In certain areas of Tennessee Valley, it's a little bit higher background. It's like 4 or 5 counts compared to the rest of the world.
What we found across the network was a median of identical instruments to what William used, was generally reading about 36.6 counts per minute across the United States on a rough average. But it's important for each station to have a very solid, firm baseline with which to work with, because that's what we look at. The nature of the accelerated curve maxed out at 174 counts per minute over a 3.5-hour period. We found that's flying at 15,000 feet for 3.5 hours. It's no threat to human safety or anything. But when you don't know where it's coming from,
Freaks.
Yeah.
Well, I hope you all are going to stay at least through the coffee break.